Very good morning, friends. Myself, Dr. M. A. Chennaya. In this video, we are going to learn how to convert the given orthographic views to isometric view. Friends, I have been telling in all my previous videos on this particular chapter that whenever the isometric is to be drawn from the given orthographic views, you will have to see what are the dimensions, that is the length, width and the height. Here it is a 80 square, so this will be 80 by 80. The base will be 80 by 80 and the height is equal to 60. How 60? 20 plus 60. So I have constructed a box here with line inclined at an angle of 30 degrees to the horizontal on both the ends. This is 80 SQ means 80. This is 80. All the base sides will have 80, 80. That's the first part. What else you find, friends? There is a step at a height of 20. So that 20 I have marked here, friends. From all the corners, I have marked 20. This is 20. Again, this is 20. So I have marked all these, and this box measures 80 by 80 and the height is equal to 60. Friends, if you observe the top view, you have got two squares coming up to this height 20, which are, what are the dimension? This is 80 SQ and inside that it is what is called 30 SQ, and it is there only up to here, up to this block, this height of 20 mm. We have got these squares, two squares. And friends, these squares appear as rhombus in the isometric. So friends, this is totally 80, 80 by 80, and I have taken exactly in the center of that a dimension of 40 SQ. So 40 by 40 by 40 by 40 I have marked. And here, let me start the projection from the top because everything is clear in the top. So 80 SQ. So friends, sorry, 40 SQ, 40 square. So I have constructed 40 by 40 rhombus here. So friends, I can just join their ends like this and obtain the last square, that is 40 by 40. 40 SQ means this dimension is 40, this dimension is also 40. And again, in the same projection of 40 millimeter, that from here to here, you have got a slot which is shown by these two dotted lines up to 20 mm. So friends, what I do, I will just have another square or rhombus constructed inside this with the dimension of how much? This is going to be, you can see here, this is 30 SQ, 30, 30, 30, all are 30. And friends, there is a slot here, so I have to show that slot by this vertical line. So that indicates that there is a slot. So this part is over, friends. And here you can observe, friends, you have this up to a height of 40. So up to a height of 40 means what? I have to draw lines from there up to this height of 40. And again here, friends, we are going to have lines drawn here. Before I draw the lines, you have see some sloping surfaces on both the sides. They start from the top, end here. Exactly in the center of that 80, there is a 15 mm sloping surface. So friends, what I do, I have marked these two lines exactly in between these two and the center, and that has got a dimension of width is equal to 15 mm. So from there, this line is shown by a line here, and another line with width is equal to how much? 15 mm. Friends, this sloping surface is shown by this line in the front view, and this is the width 15. I have marked 15 here, friends. This is dimension of 15. I just mark here like this so that you will have clear picture about this. And friends, since this is a sloping surface, you have to write a vertical line from there perpendicular to the horizontal, Another line from here parallel to this surface. So friends, I am going to have a projection like this. This edge is parallel to that. Friends, this is how this sloping surface appears like this. Similarly, on the other friend, you have to mark these 2 points here and then project. If you project, friends, I am very sure you are going to have only one line somewhere here. The other line is on the other end of it. And friends, this platform is a square. Let me complete that so that you will be able to visualize it in a good way. So friends, this is the box you are having. And symmetrically on the other end, friend, you have got similar arrangement made. And here, friends, you should write a line parallel to this. So that surface is on the other end of it. So friends, let me complete this. This box, whatever I have drawn here, measures 80 by 80 and the height is equal to 20. Friends, again, if this is the front view I have drawn, there is again another sloping surface with dimension 15, actually 15. So, but that is not starting from the top face, it is starting from a distance from there that is given to be 30. So, from where it is 30 means what? I should make this projection, draw lines at an angle that is at the given height from there, and this is how it looks, friends. Again, friends, you have to draw lines vertical from there and another line parallel to this border. So if it is parallel, it will be something like this, friend. Friend, you have totally 4 projections are there, one coming from this end. And this is one projection. This is projection on the other end. There you have got on the other end of it. Then this is from a lesser height, which is at a height of 40, sorry, this is 30 millimeter. This is 40 and this side is 30, friends. And friends, you have completed this, and from all these corners, you have to draw vertical lines. So this is a square of 40 by 40. Inside slot is, that is 30 by 30, and there are projection on all the 4 sides of width is equal to 15. This is also 15, this is 15. On the other end also you get another one. And friends, this is at this height. So friends, I am going to draw a line from there. And this projection, friends, can be completed by drawing a line like that. That is parallel to the base, or parallel to this, like this. Friends, if you observe this figure, from the top view, if you see, you will have a square 30 by 30, this square. And concentrating with that, you have got 40 by 40, 40 by 40. And friends, you have got these 2 sloping surfaces represented by this line starting from the top. So this is one surface 15 width and this is the other surface which has got 15 width. But this is starting 10 millimeter below that. That this height is 10 mm. Vertical height is 10 mm. And friends, this is a platform you have got here. And friends, it is a square. So we are going to have this joint here. And friends, you can observe and just visualize this. Now, to make this figure more meaningful, I will remove all these unwanted lines so that you will be able to visualize this in a better way. So let us see, this is how it will look when all these construction lines are removed from here. Friends, I'll make some of these little more darker. So this is the top face, which is a square 40 by 40, 40 by 40, and this is another square, okay, rectangle square of height is equal to 40. Very obviously, this complete figure is a cube 40 by 40 because the height is 40, side is also 40. It is obviously is going to be a cube. And there is a slot here exactly in the center of the top face, and this line indicates that there is a hole inside, and that hole will be there throughout from there till here. But generally in isometric we don't show those invisible lines. Friends, what else is remaining here? We have got all these, that is all these lines are there, and this will give you, I think I have to remove this line because it is starting from here. So friends, now it is very clear. Let us check for the correctness of this figure. Top is a square 30 by 30. Yes, we got a slot. Then another square 40 by 40. We have that at a height of 40. This height from here to here is 40. That is clear. And there is, friends, there are four sloping surfaces. This one on the left side, the other on the right side. They will be starting from the top surface. But these two surfaces, which is wherein you have got one in front, one behind, and the same, that is not visible, and hence I have shown only this very clearly. Now, friends, this is the thing we have got here, and we may have to move little, friend, to make it symmetrical, friend. Yeah, let me complete like that. And it is starting from somewhere here, so I will have like that. So this is how, friends, you will be able to see the isometric view which is drawn to the actual dimensions of the orthographic views. And I will say this is the isometric view. Isometric view because we are using the whatever the dimension that given here in the orthographic view, same dimensions are being used here, and hence this becomes an isometric view. But in the same problem, if you want to draw the isometric projection, then it is very simple. Whatever the dimensions you have got here are all to be multiplied by 0.815, because in isometric projection, the dimensions will be 81.5 times or 0.81 times compared to that of the orthographic views. Friends, I hope the presentation was interesting and it was useful. And friends, if you like this video, do share this video and my YouTube channel with all your friends. And have a blessed day. I thank you very much for watching my YouTube video.